Alright, so we know that the difference identity for cosine is theta minus beta, cosine of theta minus beta equals cosine of theta cosine of beta plus sine of theta sine of beta. So the key thing here is difference, right? Because they're subtracted from each other. So if we take a look at our unit circle, and we denote that it's a unit circle by adding the 1, 0 here. If we have angle theta, and here on the graph, we'll say this point right here, this point is going to be cosine of theta sine of theta, right? Because if we remember from the Pythagorean identity proof, we can write the coordinates with the trig functions. So we'll say that is cosine of theta sine of theta. Just forgot a parenthesis there. But, and then we can also have, let's say, another angle, the distance of beta, or the angle beta. And then this point is going to be cosine of beta sine of beta beta. Then it's different, remember, so if we subtract these two angles, this distance here would be theta minus beta, right? So, but if we wanted to measure that angle, it'd be hard to do it from here, because where do we measure angles from usually? We start at the x-axis there. So if we take this angle, the segment of the circle, and we just move it down here, just translate it down there, we would have this theta minus beta. Then this point here that would correspond to it, we could call cosine of theta minus beta sine of theta minus beta. So now what we can say is we can say that because we just translated it, this distance here from, it's more of a straight line, it's not on the curve, it's a straight line from theta, cosine of theta, sine of beta, to, or cosine of theta, sine of theta, to cosine of beta, sine of theta. We'll call that d1. It's a straight line, it's not in the circle. The distance is the same distance as cosine of theta minus beta, sine of theta minus beta, to 1, 0, because all we translated it. And this is d2 here. So what we want to prove is that d1, again, the distance between cosine of theta, sine of theta, to cosine of beta, sine of beta, is equal to cosine of theta minus beta, sine of theta minus beta. And this will give us the difference identity for cosine. So we'll take this on another paper. So we're trying to find the distances, right? So we'll need our distance formula, which we know is derived from Pythagorean's theorem, and it gives us x2 minus x1 squared plus y2 minus y1 squared, and that is all under square root. So if we look back at our graph here, let's try and get them both in frame. We know that, so we're trying to find this between this point and this point first. So we'll say d1 is equal to square root of we'll say the cosine of beta is x2. So we'll say cosine of beta minus cosine of theta, which will be our x1, cosine of theta squared plus, we'll say, because we chose cosine of beta as x1, we'll say the sine of beta is our y1, but in the end it wouldn't really make a difference because while the order you subtract does matter, we're squaring this quantity, so it would take away the order of subtracting mattering. So we'll say, we'll just do it for consistency's sake, we'll say sine of beta minus sine of theta squared. And then actually put this over here. And then so then D2, bring it back actually, D2 is going to be equal to the square root of cosine of theta minus beta minus 1 squared plus sine of theta minus beta minus 0. Because that's what we're measuring, right? We're measuring the distance between this to the distance to 1 comma, from here to 1 comma 0. So that's why we have the 1 and 0 there. And then once we bring this square root over, because we're trying to prove that those two distances are equal, right? It makes sense that we would set them equal to each other. So we'll say that the square root of cosine of beta minus cosine of theta squared plus sine of beta minus sine of theta squared is equal to cosine of theta minus beta minus 1 squared plus sine of theta minus beta minus 0 squared. So now what we can do is we can solve this, right? To see if they can be to come out with the identity. So first thing we would do is we would square both sides, right? And that would get rid of the square roots here. So we would end up with cosine of beta minus cosine of theta squared plus sine of beta minus sine of theta squared equals cosine of theta minus beta minus 1 squared plus sine of theta minus beta squared. And we can take that out of the parentheses and just write that as sine of theta minus beta squared, because there's nothing else in there, because all that was in there with it is 0, and then we can distribute everything out. So this would give us cosine squared of theta minus beta and then we would get, if we multiplied this way, we would negative 2 cosine of theta minus beta. Okay, then from there we would get, we'll start on this side actually, we'll get cosine squared of beta minus 2 cosine of theta cosine of beta. Then we would get plus cosine of theta squared plus sine of beta squared minus 2 sine of theta sine of beta. Then here, we ran out of room, so curve up here we get plus sine squared of theta. So just to double check that these are right, we would get this. In the middle we would have negative cosine of theta cosine of beta, and then negative cosine of beta minus beta. Okay, so that's right. So then from here, we know that these cancel out to be 1. So we have 1 because of our Pythagorean identity, remember, which is cosine of theta squared plus sine of theta squared equals 1. We have a cosine of an angle squared plus a sine of an angle squared, and that'll give us 1 minus 2 cosine of theta minus beta equals, we have sine squared of theta, cosine squared of theta, that'll give us 1, positive 1, we have sine of beta squared, cosine of beta squared, that'll give us 1, so those two are gone, and then from there, we have another 1 here on this side, because 1 times 1 is 1. So plus 1. Alright. So then from there we have negative 2 cosine of theta cosine of beta, then negative 2 sine of theta sine of beta. So we can, let's just simplify this, make it look a little neater because it's a little jumbled there. We'll say negative 2 cosine of theta cosine of beta minus 2 sine of theta sine of beta. And then there's 2 1s here, say plus 2, because remember that we simplified the cosine of beta squared and sine of beta squared and cosine of theta squared and cosine of, or sine of theta squared cosine of theta squared to 1. So then we got 2 because they both simplified to 1. Then here we have a 1 and a 1, so we'll say 2 minus 2 cosine of theta minus beta. Then from here we can subtract these two. We can subtract this 2 from this side and from this side. That'll simplify to negative 2 cosine of theta cosine of beta minus 2 sine of theta sine of beta equals negative 2 cosine of theta minus beta. Then from here we can divide both sides by negative 2, and that gives us our identity, which would be cosine of theta minus beta equals cosine of theta cosine of beta plus sine of theta sine of beta. Sorry, I ran out of a little room there. I'll write it on the back here. That's be the end. Again, the end step was negative 2 cosine of theta cosine of beta minus 2 cosine or sine of theta sine of beta plus 2. Remember from the Pythagorean, the use of the Pythagorean identity to simplify that a little bit further. We have 2 minus 2 cosine of theta minus beta. And then from here, we just subtracted the 2 over. We have negative 2 cosine of theta cosine of beta minus 2 sine of theta sine of beta equals negative 2 cosine of theta minus beta. And then we divide both sides by negative 2, and it gives us our identity, which is cosine of theta cosine of beta plus sine of theta sine of beta equals cosine of theta minus beta. That's it.